Hello, in this video I'm going to go over a couple of tips about how to solve homework 1. Okay, so let's take a look at homework 1, which like all homeworks has two problems. This homework's all about making conversions, so converting one quantity into another. So in the first problem we're converting time, and the second one we're converting distance. So if you look here, in problem number 1, I say assume the age of the universe is 13.787 billion years. Okay? So the idea is that many real years, or Earth years, is equivalent to one cosmic year. Okay? Because it says that the cosmic calendar, all that time, the 13.787 billion years, is one calendar year on Earth. In other words, one Earth year. So the idea is we say 13.787, and then you want to convert that billion to scientific notation, so it'll be times 10 to the 9, because the billion has 9 zeros, is equivalent to, and that's, let's put the years on that, and we call this EY for Earth years, and that's going to be equivalent to one cosmic year. Okay, so that sets up a conversion. You know that many Earth years is equal to one cosmic year. And then I ask how long is 25 Earth years in cosmic years? So the idea there is instead of having a huge number of Earth years, instead you're just going to have a small number of Earth years. So this, by the way, is number 1. So in this case, just be 25 Earth years. Okay, and we want to find out how many cosmic years that's going to be. Okay, so what you need to do then is you just need to solve these two equations to solve for this unknown. How many cosmic years is 25 Earth years? Now the answer you should expect is going to be a very small amount of time. And as I say here, give your answer as a fraction of a cosmic second, because you're going to get a very small fraction when you solve for number of cosmic years for 25 Earth years. Okay, but of course you would, because one cosmic year is 13 billion, almost 14 billion Earth years. So just 25 Earth years is a very small fraction of one cosmic year. Okay, all right. So that's the approach. Solve for that fraction, and then you want to, when you convert it over to seconds. By the way, you have to consider how many seconds are in a year, and a year has 365. That's the number of days, times 24, the number of hours in a day, times 3,600, which is the number of seconds in an hour. Okay, that's how many seconds are in 1 year. Okay, in 1 year. Okay, now these would be cosmic seconds because these are the number of seconds in one cosmic year, but of course that would hold true for Earth years as well. Okay, all right, so hopefully that makes sense for the approach for number 1. Looking at number 2, again, all about conversions, but this time distances. The problem states, consider a 1 to 10 to the 19th scale on which the disk of the Milky Way galaxy fits on a football field. And I give you the dimensions of the football field that we're using in this problem, 91.4 meters. On this scale, how far is it from the Sun to Alpha Centauri, which has a real distance of 4.4 light years? How big is the Sun on this scale? And compare the Sun on this scale to the actual size of an atom, which you're going to estimate as 10 to the negative 10 meters. And give all your answers in meters and in scientific notation where appropriate. Okay? Of course, you're not going to give the fraction in any units because it says how big is compare this to the size of an atom. So then you're just going to be making an inequality right here for the comparison. Okay? Now, the first thing you want to do is you want to find the actual size of the Milky Way because they don't give it to you. And you could look it up and find that it's about 100,000 light years, but that wouldn't be using the information in the problem. Instead, you're going to use that 91.4 meters that's given. So the idea is you know the scale, what is often called the scale factor, that our scale model of the galaxy here is 10 to the 19 times smaller than the actual galaxy. So in other words, you have to say, okay, well, if the scale is 91.4 meters long, so we'll say the model size is 91.4 meters, well then to get the actual size of the galaxy, so then the galaxy size is then going to be equal to 91.4 meters simply multiplied by the scale factor, which is 10 to the 19. That's going to give you the size of the galaxy in meters, okay? So that's going to be in meters. Okay? So what you need to do then is find out what fraction of that size of the galaxy in meters is this little distance from the Sun to Alpha Centauri, because that's a tiny fraction of the overall galaxy, because after all, the galaxy has 100 billion stars in it, so the distance between any two stars is very small compared to the overall size of the galaxy. Now I give you that real distance in 4.4 light years. What you want to do is convert that light years to meters. So convert 4.4 light years, because light years, although it sounds like a time, are not. Light years are a distance. It's a measure of how far light travels in a year. That's 1 light year. In this case, 4.4 light years would be how far light travels in 4.4 years. Okay, so 4.4 light years. Convert that to meters. Okay, and to convert from light years to meters, you just need to look up how many meters are in a light year. I don't give it in the problem because that is included in the appendix of the textbook and so on, but I'll go ahead and mention it here in the video. So if we just look up meters in a light year, it's a number that I never remember, but there are 9.461 times 10 to the 15 meters per light year. That's how many meters are in each light year. So you'd simply then find out how many meters are in 4.4 light years. Right? I think that's obvious how to do that. And then compare that to how many meters are in the galaxy as a whole. That will give you then the fraction of the overall diameter of the galaxy, which is the scale model size of the football field, right? And once you have that fraction, simply multiply that fraction by the size of the football field. And that will give you the distance in the scale, okay? And then that will be a very small distance because I'm asking you to compare it to the size of an atom. So in other words, if we had a scale model of the entire galaxy that was big, right, football field large, the actual individual stars would be incredibly small because there's so many stars in this galaxy, okay? And that's what you're gonna find, that actual scaled distance, okay? So again, both these problems, all about conversions. Hopefully this gives you a good start. Thanks for watching.